Good afternoon. I am Jatinder Garg. I am Associate Professor at Baba Hero Singh Battal Institute of Engineering and Technology, situated in Lavagaga, Sangrur. Today, I will be discussing a topic in the Manufacturing Processes 2 subject of Mechanical Engineering course of BTech classes. The topic will be Introduction to Metal Cutting, and we will be mainly concentrating on the basics of cutting tools. Let us try to learn what is the machining process. We know that all the cast, formed and shaped products may need further machining operation to give them the desired final shape after removal of extra material in the form of chips. All the manufacturing processes can be broadly classified into 4 categories. One is fabrication, the other one is casting, the third set of techniques is known as forming, and the fourth and the very important one is a machining process. Although the parts that can be manufactured by any of these processes, and depending upon the quality that we want to achieve and the cost effectiveness of manufacturing of that particular part by that particular manufacturing process, we use the suitable manufacturing process to form that part, and thereafter for the final processing of the part, normally some machining is required so as to give that part the final shape and size as per the tolerances and the dimensions, and for this purpose machining processes are used. In machining process, we remove the material in the form of chips to give the product, the piece the final shape. The machining processes remove material in the form of chips as is written here. The chips may be cut by means of cutting, as in the case of machine tools, just like lathe machine or shaper machine. Here the extra metal is removed in the form of small chips, and in some machining processes such as in grinding process, we use a grinding wheel whereby the metal is removed in the form of small small chips in the form of say the process can be said as abrasive, and there are some other type of manufacturing processes also which comes in the category of special manufacturing processes, whereby the material is neither removed in the form of chips or in the form of abrasive material, but using some non-traditional methods. These type of manufacturing processes whereby we remove the material in non-traditional processes involve some special processes such as electro discharge machining, electrochemical machining or similar such processes, and is mainly used for machining those materials which are harder and are difficult to be machined using the conventional processes. We in this lecture we will mainly be concentrating our subject on the these two aspects, the cutting and the abrasion, and non-traditional machining processes we will not be discussing in this lecture, and it is a subject of it is a separate subject, and we will be dealing with it when you will be in higher classes. Metal cutting processes, main metal cutting processes has been shown here in this slide. This particular process which is turning, here the metal is removed using a lathe machine normally, and in this process the workpiece is rotating, and the tool, which is a single point cutting tool having only one cutting edge, is made to be rigidly fastened onto the tool post, and the workpiece which is rotating is fed with respect to this tool, so as to remove the excessive material in the form of small chips. The second type of manufacturing metal cutting process that is normally used is a shaping process. The only difference between the turning process and the shaping process is whereby in turning process the tool is held stationary and the workpiece is rotating. In this process the tool is moving and the workpiece is held stationary. And furthermore, in turning process, the tool is rotating and it is mainly used for finishing the rotary jobs, whereas in shaping or planing, the purpose of the machining is to produce flat surfaces, and the motion between the tool and the workpiece is also linear. The third manufacturing process in metal cutting category is the milling machine. In milling machine, we are having a cutter which is having multiple cutting edges, and these cutting edges are fed to the workpiece one by while the cutter is rotating, all the cutting edges are moving the metal from the workpiece when its turn comes, and the metal is removed at a much faster rate than that is done in the case of the other processes where only a single tool is doing the work. So, similar other processes are broaching, the drilling and the grinding. Normally, if we apply our common sense, then we can think that the grinding may not, we may not think that the grinding should also come in this category, because in grinding no chips or no removal of material in the form of small bits and bits of material is coming, but and moreover no actual sharpened cutting edge is we come across in this process, but for the purpose of grinding, the small abrasive particles that are there in the grinding wheel are taken as single point cutting tools, and the material that they remove in the form of miniature chips is usually appears as a heap of sand or a grind powder of the metal piece that is removed from that workpiece. Let us discuss what is the cutting tool. A cutting tool is any tool that is used to remove metal from the workpiece by means of shear deformation. It is one of the most important components in machining process. It must be made of a material which is harder than the material which is to be cut, and the tool must be able to withstand the heat generated in the metal cutting process. In this slide, we have tried to summarize that what is a cutting tool and what should be the essential properties of a cutting tool. As we have seen that a cutting tool is essentially anything which is used to remove the material or to cut the material from the workpiece. And the most important thing is that the cutting tool material should be harder than the material which is to be cut. It is so because otherwise the wear and tear of the cutting tool, which is much more than that of the wear and tear or the removal of material from the workpiece, and hence we will be forced to grind or resharpen the cutting tool again and again, which will lead to a lot of non productive time and which will be against the economics of the machining process. So, we choose a material which is harder and tougher in some cases, and we will discuss how the two things, the hardness and the toughness, is to be taken care of, or the trade off between these two properties which are conflicting in some respect is to be taken care of. But let us now try, if we at this point we should only try to learn that the material of the cutting tool should be harder than the material which is to be cut by this cutting tool. And the second thing is that in the cutting process, when the cutting is going on, a lot of heat is generated, and in case the material of the cutting tool is such that it gets softened at elevated temperature, then the actual purpose of the cutting will be lost, and the material which be much softer than that of the workpiece, and the same problem will occur, and we will be required to sharpen the cutting tool again and again, which will not be economical, as I have already told. So, to avoid these things, the two things, that the material should be harder and it should be able to withstand the elevated temperature, or it should be having hot hardness, is very important. The machining tools can be classified into two categories broadly. Is single point cutting tool, the cutting tool that we use in the case of a lathe machine, and a shaper machine or planer machine is usually a single point cutting tool and a multi point cutting tool. If we look at these two pictures, then we can directly see that in a single point cutting tool there is only one cutting edge, whereas in a multi point cutting tool there are a number of cutting edges which are fed into the workpiece intermittently. Let us try to learn some basic points or basic terminology of the cutting process, although we will not be elaborating these things much, and we may take a part of this in the further slides. But to have a glimpse of the terminology, the basic thing or the basic important parameters that determines what is the machining rate or the amount of material or the metal removal rate in the workpiece are these three parameters, which are known as speed, feed and the depth of cut. Speed is the speed by which the cutting tool is moving with relative to the workpiece. The relative motion between the two, the speed of the relative motion between the tool and the workpiece is essentially the speed of cutting. The feed is advance of tool through the part, and the depth of cut is this portion, how much this tool is cutting in this one go. If we look at this single point cutting tool, then this face, the upper face which faces the chips, this face in this picture, if we see this particular face which face the chips and the chips slide across this face, this particular surface is known as a rake face, and the angle which is given to this face, it may be a positive angle as is shown in this case, or it may be a negative angle. In both the cases, this particular angle is known as a rake face angle. This face which faces the finished job, this particular portion of the tool is known as flank, and the angle given to this portion is known as the relief angle. Here we can see a more clear picture of a single point cutting tool. These are the tools, the single point cutting tools that are usually used on a lathe machine. We can see here there are a variety of shape of chips. These are actually carbide tip tools which are used, which are much harder than the high speed steel tools that we normally use in our college workshops, which look similar, which give a metallic luster just like a just stainless steel. That particular material is although cheaper, but being lesser harder or being softer than these type of carbide tip tools, it requires regrinding again and again, and in case we are doing some sort of professional turning, whereby the productivity rate and the labor cost and the machine cost, all these are much more important, or in case we want to machine some harder material which cannot be machined using those high speed steel tool chips. In that case, we are normally using these type of carbide tip tools, and which are mechanically fastened onto these flanks and are doing its purpose. One important thing is these carbide tip tools, or these cannot be regrind. They can only be used once in a while. We suppose we are using this type of chip, then first of all we will use this edge of this chip, and then the second edge can be used, then the third edge, and then the fourth edge, and then the other portion can be used, the other side can be used. But ultimately, when all the sides have worn out, it has to be thrown away. The turning process, if we have a closer look at the turning process look just like this. In simplified terms, it is having a rotary workpiece which is rotating, and a single point cutting tool is made to feed into this rotary workpiece, and it is made to travel in this direction so as to cut the material from the workpiece so as to give the desired shape. As I have told you earlier, but in this case the planing and shaping the situation is a bit different. In this case, the workpiece is not rotating, rather it is a straight piece which is held stationary, and the tool which is just like the tool which is used here, a single point cutting tool. A similar tool is used in this case also, but in this case this tool is rather moving in a linear manner, and the relative motion between the workpiece and the tool is linear. So, that ultimately the end product of this machining process will be a flatter surface and a plane surface, rather than being a rotary surface as was there in the case of turning machines. We can read out the workpiece is moved back and forth under the cutting tool and is fed sideways a set amount at end of each table reversal, so as to produce the total surface. The meaning of this second line is that when this tool is traveling, suppose the tool is at this particular position at the start of this back and forth motion, then it will remove a chip, as we can see over here the chip is being removed by the tool when it is moving relative to this workpiece in this direction. Then once this cycle is complete and this whole slab has been made plane, as has been done over this portion, then again since the depth of this cut is such that if we move the tool further in the same direction, then there will be no material which has to be cut in the path of the tool, and so as to do machining on the whole surface. What we do, we set the machine in such a manner that after this cycle is completed and the tool has been moved to this position, when the tool returns, it moves in this direction a bit, so that now it is at this position and it is removing the material which is there to the side of the material which has already been removed. The second category of cutting tools is a multi-point cutting tool. As I have told earlier, a single point cutting tool is having only a single cutting edge, as we can see here. But in this case, in the case of a multi-point cutting tool, the cutting tool is having number of teeth. We can see in all these pieces that there are a number of cutting edges which are there on the periphery of a ring or on a drill bit, but the edges, these edges now are responsible for doing the cutting that is to be done by the machine, and they are fed into the workpiece intermittently, as has been shown in the working of this milling machine. These three cutters are milling cutters. They are having these are also milling cutters, and these are also milling cutters, but this the difference between these milling cutters is when this type of cutter is used for shearing or cutting of the slabs, this type of cutter is used mainly for the plane milling, whereby we want to produce a flatter surface onto a workpiece. And depending upon this, these type of tools are also used for gear cutting, and depending upon the sophistication of the machine that we are using for, and the sophistication of the cutting tool that we want to use, and depending upon the job that has to be machined and the material of the job that has to be machined, these type of cutters are also available in this sophisticated manner, whereby it is just like an end milling cutter which is shown over here. The only difference between this cutter and this cutter is that in this cutter the edges have been ground onto the same shaft. From the same piece the teeth have been ground, and once after the use if these teeth get blunt, then they have to be reground, and once the regrounding limit has been exceeded, then the whole workpiece or the whole tool or the whole this cutter needed to be replaced. But in this case we can use the inserts, so that after the machining has been done and the edges have been got blunt and they need to be replaced, we need not replace the whole cutter, and we can replace only these edges which are mechanically held into the body of the main cutter using some mechanical means. A drill bit is also a multi-edged cutting tool and it is a typical example of a two-edged cutting tool. If we are asked some question that which tool is a single double-edged cutting tool, then we can say that it is a drill bit. Then I need to elaborate how this drill bit can be said as a two-bit cutting tool. We can see that there it is, this drill bit is having two cutting edges at the base. One is over here and the second is over here. So that there are ultimately two chips which are coming out when the drill is being operated, as we might have seen while working in the workpiece. So, this drill bit is a typical example of a double edged cutting tool. Then as I have already explained in details while discussing the general features of the multi-point cutting tools, a plain milling cutter is a typical example of a multi-edged cutting tool. If we read out the slide, the multi-tooth tool having several equally spaced cutting edges around its periphery. We can see here that it is a tool which is having a number of edges and which are placed on the rotary periphery of this particular tool. Each tool is considered single point cutting tool. Workpiece held in vise or fastened to table and is fed into horizontal revolution cutter. Each tool makes successive cuts, produces smooth, flat or profiled surfaces depending upon the shape of the cutter. What we mean by this paragraph is that in this type of machining, although we are having a number of cutting edges which are placed on the periphery of the cutting tool, but still we can, while studying the machining process, we can still consider, or we can still safely assume each and every edge or each and every cutting edge of this cutting tool to be just like a single point cutting tool. So, the basic unit of any cutting tool is basically a single point cutting tool. This I have already explained. This is an insert based face mill, and the features I have already explained to you. In insert based face mills, we use some mechanically held inserts as cutting edges, and these inserts can be replaced when they get blunt. But in case of these integrated cutting tools, since the edges have been ground onto the same shaft or same shank or the same body of the workpiece or the cutting tool, so it is not possible to replace them and they are required to be reground. End milling cutter. End milling cutter is a multiple fluted cutter having vertical or vertical milling machine spindle or attachments, used primarily for cutting slots or grooves. Workpiece is held in vise and is fed into a revolving cutter. End mill is mainly used for cutting of periphery of teeth. Let us have a discussion on the cutting tool materials. The main cutting tool materials that we usually use for making the cutting tools are high speed steel. High speed steel is a material which is most commonly used in our workshops in the colleges and laboratories or workshops. It looks just like the stainless steel if it is having a shiny surface, and we might have used this high speed steel tools for working on lathe machine while we were doing our workshop practice in the first year, and so that particular material is known as high speed steel. The second type of material which is normally used is cast alloys. The cemented carbide tools that I have shown you in the previous slides is also very widely used for the industrial purposes. Ceramic tools, cement tools, cubic boron nitride tools and polycrystalline diamond are also sometimes used for machining harder surfaces which cannot be machined using these conventional materials. Cutting tool properties, as I have told you in the first slide while we were discussing what is a cutting tool, the various cutting tool properties that are important for the material to be selection as cutting tool are. One is hardness. The cutting tool material must be at least 1.5 time harder than the material that is to be cut using this machine tool. Otherwise, it will not be possible for us to cut the workpiece using that particular tool. That is why sometime we are even using polycrystalline diamonds for cutting very harder material, since diamond is the hardest material available on the earth's crust. The material should be capable of maintaining a red hardness during machining operations. Red hardness means that since when machining is going on, both the temperature of the job and the workpiece goes up. Although we use coolants and the similar arrangements to lower down the temperature of the cutting tool as well as the workpiece, but still the temperature in the cutting zone is very high. So, it is very important for the tool material which should be able to withstand high temperature. The third important property is wear resistance. To avoid frequent resharpening and wearing out of the tools, we should use a material which is having a property that is having sufficient wear resistance, so that the material do not wear out while the operation is being carried out, and we need not grind it again and again to save our production time. Basically, when we discuss the economics of production, we can see that the total machining time can broadly be classified into actual machining time and the setup time. While the actual machining time is the time when the tool is actually doing some sort of cutting and the tool is actually engaged in the cutting operation, and the setup time and the other non-productive times are the times such as the times required to unfasten the tool from the machine, the time required to resharpen that tool, and then again mounting the tool onto the workpiece or the machine post or wherever it fits onto the machine. And in case we require resharpening and replacement of the cutting tools quite often, then the total proportion of the setup time in the total machining time which will be much greater than the actual machining time, and as a result the total non-productive time will go much higher than the productive time in the total working cycle, which will seriously hamper the total productivity of the worker, the machine as well as the whole process. The fourth very important property in case of the tools like just like lathe, which are being used in lathe machine, and the tools this is very important in case where the tools are fed intermittently, is the shock resistance. The tool material should be having sufficient toughness so as to be able to withstand sufficient shock which it come across while the machining is being carried out, so that the tool edges may not break off. In case the tool material in the cutting edge comes out while we are doing the machining, then again we will have to replace the tools, and in addition to the cost of that damaged tool, we will also incur the non-productive time of replacing and resharpening of the tools, as the case may be. That I am saying this line because in some cases, just in the case of say a single point cutting tool which we use in lathe machine, even if the tool breaks, we can regrind it in case of course HSS tools, and but in case milling cutter breaks, one or two edges breaks off, then we will need to replace the whole cutter and the cost will be much more. So, it is very important to know that the shock resistance of the material out of which that tool has been made is sufficient as per the requirement of the operation that it has to go in, or in other words we can say that while selecting a tool for carrying out a particular job, we should also keep in mind the toughness of the material of the tool that out of which the tool has been made, so that the tool may not break in between the working. It may also lead to some injury in addition to the financial losses that I have explained earlier. Shape and configuration, the material of the cutting tool should be such that it should be easier to manufacture that cutting tool from the blank from which it is to be made. The most common material is high speed steel. The most tools that we come across in the workshops are made of high speed steel. This high speed steel